So not only do we know linear functions have constant rate of change, but we also know that linear functions will also have a situation going on for it where we would be able to know and understand that each linear function really highlights a y-intercept as well. Now, in terms of functions, we kind of sort of consider it an initial value. So we're more used to seeing it in terms of function notation written out as f of 0, and that 0 being that x value, where we understand that if this was on a graph, we would be seeing something to the point of maybe like 0, y, where we don't necessarily know where the y value is. So a lot of different ways to represent this intercept, and I guess the y-intercept would be more of a graphical, geometric way to represent it. So figuring out what the y-intercept is in a function is certainly an important thing for us. Here, going back to this example with the table, this is the process that I would go about. There's plenty of different processes to getting to a y-intercept. I have this table, and in this scenario, I know the rate of change. I'm going to go ahead and use that linear function model that we have, y is equal to mx plus b. Sometimes we've also seen it as f of x is equal to mx plus b. Either way, same exact thing. And we previously learned that we have negative 3.5 as our constant rate of change, which is our slope. In order to figure out the y-intercept, which is this b value here on the back end of any linear function, I can take any point on this table, throw it into the equation, and calculate the b value. So I'm going to go ahead and do that with 1365 and 10. So I'm going ahead and using this as my x value, and I'm using this as my y value in this function. It would work for any singular point. I'll go ahead and do the math work here on this. If I add 35 to both sides, that would take me to 1400 as my b value after I got done adding 35 to both sides. So in this scenario, my y-intercept, if I had another table, I'll do some erasing here of previous situations. This table can continue to extend upwards. All right, and in this scenario, we know that 0 would produce a y value, or in this case, a output of 1400, which in this scenario means that when this bag, in this example, when this bag is first given to someone, it would have 1400 milliliters of volume in it. So again, that's the process that we use in order to work backwards to get to a y-intercept, or our f of 0. In this case, this function would be written out as f of 0 is equal to 1400. And of course, on a graph, it would be 0, 1400. So many different ways to explain and to display a y-intercept for a linear function.